is
nitrogen.
21% is oxygen. 1% is argon and other natural gases. You know? So that's 100%. Where's the CO2? 0.01. You know, and so of that 0.01, now you're talking about the parts per million.
Okay.
Now you're talking about the parts per million. So I just read this online, rehearsing some of the stuff that I've read about this, is if you were taking an airplane ride from Los Angeles to New York, what percentage is 330 parts per million of that trip? You know, and in other words, where would you be across the United States if you were flying from Los Angeles to New York? What would be the percentage of 338 parts per million? And the answer is halfway down the runway at Los Angeles Airport, getting ready to take off. You know, it is so small.
Yeah.
Okay, so that's my first argument, okay? It's hugely small. It's ridiculously small, okay? But the second thing, and the thing I wanted to tell you, this is the biggest thing I would say, okay?
Okay.
This is the biggest thing I want to say to you in this conversation. Every climate model on the part of global warming scientists that say we're responsible depends upon reinforcing factors. Like everything we do gets multiplied times 3. Okay? So if we increase CO2 production, they assume in their models that it's going to be reinforced by a factor of 3. Well, okay, let me give you a visual example.
Okay.
You've got a ball, okay, at the bottom, at the top of a bowl. Turn the bowl upside down and put a ball on top of it, okay?
Okay.
It doesn't want to stay there. So if you push the ball, if you touch it, it will roll off the bottom of the ball. Okay?
Okay.
Okay, that is called positive feedback. Every disturbance, everything that you do to that ball is going to be amplified, is going to be reinforced in a feedback loop that's positive, like it increases the effect of something. Every climate model says no matter how much CO2 you increase into the Earth's atmosphere, it's going to have a positive feedback effect. Factor of 3, usually, in the scientists' models. All right?
Mm-hmm.
Here's the metaphor. Turn the ball upside down. Turn the ball over. And you put the ball at the bottom of the bowl. Okay? And you hit that ball. So you thunk it with your finger. This is called negative feedback. No matter what you do to that ball, even if you hit it pretty hard, where's the ball going to end up?
In the bowl.
In the bottom of the bowl. Okay? So, think about the climate this way. Let's suppose we do something that increases. Now, global greenhouse gases are 95% water vapor. Okay? The CO2 production is less than 1% of the greenhouse gases themselves. Most of it's water vapor. Okay? But let's suppose CO2, and I do agree, it does add some heating effect to the atmosphere. There's no question about that. Theoretically and practically, our CO2 production does add some minuscule, I'll grant you. Okay?
Okay.
So let me just say, I grant you that. And you say, hey, Mr. Yogi, you just granted that. And I'll say, yeah, but then what happens? Then what happens is we produce, because we're warmer, more clouds. What is the effect of a cloud in the atmosphere? The effect of global warming, of any kind of warming, for example, now you've got more water vapor in the air, and the oceans produce more clouds.
Yeah.
So what happens when the sunlight hits a white cloud? One of the things I remember back when people really panicked about this is they said, "Oh, we're going to have these airplanes go up and distribute particles, like shiny particles, in the atmosphere, and they will reflect light back out into space."
Yeah.
People were really concerned about this after Al Gore. They were panicking, and they said, maybe we could put these little white shiny particles up in the atmosphere and reflect sunlight back out into space.
Yeah.
Well, okay, you can do that, or you can just have clouds. And once you have clouds, the whiteness of the cloud also reflects heat back out into space. Sure. I mean, when you have a hotter environment like Venus is runaway global warming. Venus is runaway, too much heat, too many clouds, more heat, right?
Yeah.
That's Venus. You don't want to live on Venus, right? Too much clouds, too much heat, and all that kind of thing. Nevertheless, the clouds on Venus do reflect lot of heat from the sun back out into space. Right?
Yeah.
So here's the ball at the bottom of the bowl. We hit it with a little, now I'm granting a little heat increase. There's no question the environment is heating up a little bit. But you hit it with a little heat increase, and in other words, it's going to have a negative feedback loop and come back to the basic temperature where it started in the first place. Because of various things. I mean, you can radiate heat back out into space, you can have clouds form and they will heat back out into space. Do you see what I'm saying?